I want to show you how to simplify a rational expression that we call complex rational expressions, which is actually a rational expression over a rational expression. Can we reduce this down? So if you look at this example, we have 1 over x plus 1 over y divided by 1 over x squared plus 1 over y squared. And remember, dividing by a fraction is the same as multiplying by its reciprocal, but this is not together as one fraction, so I can't do that yet. But that is a clue to what we should do. Maybe I should get a common denominator in my numerator and get a common denominator in my denominator, so I can bring those together, and then I'd have simply one fraction divided by another fraction. That's the strategy we want to apply. Okay, so first I'm going to look at the numerator, and let me bring it down by itself just for simplicity. So I have 1 over x plus 1 over y. I want to get a common denominator, bring these together. We can see my common denominator is going to be xy. So what I'm going to do here in my first term to get that is I need to multiply y over y. So I end up with y over xy. In my second term, I need to multiply by x over x to get that common denominator. So I end up with x over xy. Now I can bring them together and have y plus x over xy. Okay, that now is my numerator. That would replace this up here. Okay, now if I do the same with my denominator, I have 1 over x squared plus 1 over y squared. I want to get a common denominator. We could see then, I think, that the common denominator is going to be x squared y squared. So my first term, I need to multiply to get this common denominator. You just think, what's missing? The thing that's missing is a y squared. So I have y squared over y squared times this, 1 over x squared. I end up with a y squared over x squared y squared. Now in the second expression, I need to multiply, again, what's missing from here to here? The x squared. So simply multiply in x squared over x squared. So my numerator end up with x squared divided by x squared y squared. So now I have y squared plus x squared divided by x squared y squared. That is now my denominator. Okay, so now I need to combine these two things. What I have now, so this expression now becomes y plus x over xy divided by x squared, y squared plus x squared over x squared y squared. Okay, now remember though, so this is the expression right now. Remember, division of a fraction is the same as multiplying by its reciprocal. Okay, so I'm going to clear off a little room for me to do some work. That means I have y plus x over xy times, I want to turn division into multiplication. I need to take the reciprocal. Okay, now one thing we have to notice, x squared y squared, I can cancel out with xy. Look, one x is going to cancel, one y is going to cancel. Do these cancel? They do not. Okay, because this does not have a factor of y plus x. Remember, you can only cancel if you can factor it out, and we can't. So I'm left with then xy times y plus x over y squared plus x squared. And there you have it. It's not pretty, but it looks a lot better than it did where we had fractions over fractions. Here we're going to simplify 1 over x plus h minus 1 over x all over h. And so this is a complex rational expression, and this one's not quite as complex as the last one because our denominator only has h in it. It doesn't have fractions in it. So the strategy is still the same though. So I need to take the numerator, which is this 1 over x plus h minus 1 over x, and I need to combine those together as one rational expression. And so to do that, I need to get a common denominator. So I'm going to have x times x plus h as my common denominator. And then I just look at the first term and think, what do I need to multiply this by, this x plus h by, to get x times x plus h? And so I can see the thing that's missing then is I need to multiply by x over x. So my numerator, I just simply have an x. And on the other side, I see what's missing from my common denominator here, is an x plus h. So I need to multiply by x plus h over x plus h, and so that gives me an x plus h in the numerator. And now I can bring these together as one expression, and I have, and don't forget that you should, since I'm subtracting, I need to make this a plus and go ahead and change my signs up here, and that way I don't forget to distribute that negative, which is a very, very common mistake. Okay, so then I have a common denominator of x times x plus h, and in the numerator I have x plus a negative x, and those go away and just end up with a negative h, and that's my new numerator. Okay, now the denominator, well, there's not really much to do there, it's just h. So then my expression then becomes, let's see, negative h over x times x plus h, and I got that from the new numerator divided by the new denominator, which was the same as the old one, which was h. Now remember, the reason this works so well is because now I have everything together. I remember that dividing is the same as multiplying by a reciprocal. So this is the same thing as saying negative h over x times x plus h times the reciprocal of h, which is 1 over h. Okay, so now I can see that the negative h and the h cancel, and so when this thing simplifies to be negative 1 over x times x plus h, and that's my solution. Okay, I hope this makes sense. Simplifying complex rational expressions is very useful. Actually, this question we did here is something that you might see in calculus, and just understanding how to simplify these things, which can be really ugly to begin with, but then simplify to something that's not so bad. It's a very useful trick to know how to manipulate these. If you have any questions, please let me know. I'd be glad to help, and thank you for watching.